Okay, in this video, and it will be a short video, we're going to look at transformers. Now, there's a couple of theory aspects that you might want to consider when looking at transformers. That we wrap our windings around a metal, some sort of metal core. Why do we do that? Well, we want to get a better mutual conductance. But what we do is we then laminate it. Why do we laminate it? Because we want to reduce what's called eddy currents. So there's a couple of little bits and pieces like that that you might want to consider. But for the most part, we're going to be looking at step up and step down voltage. Okay, let's get cracking on with this then. Okay, so the basic formula we've got, so we've got the number of windings on the primary opposed to the number of windings on the secondary is equal to the voltage, the ratio of the voltage on the primary to the voltage on the secondary. So we can use this to either state whether it's going to be a step up or step down transformer. Okay, so let's have a look at an example. Okay, so if we look at this, if we've got 200 windings on the primary, 10 windings on the secondary, and then we can then put that basically into the equation. So we've got to go have 200 over 10 is equal to 100 over V2, just like that. Okay, so we can do a little bit of rearranging. So we've got 20 then is equal to 100 over V2, so we can make V2 the subject of the formula, which gives us 5 volts. Okay, now whilst I've just wrote that as 20, that strictly speaking, our ratio of primary to secondary is 20 to 1. So we've got 20 windings. For every 20 windings on the primary, we've got 1 winding on the secondary. Just it could be expressed in different ways, okay? Okay, one final thing before we move on to another example. If we say that the resistor that we've got just here, if we say that that's a 3 ohm resistor, we can work out what the current is in that resistor. Okay, so resistance is still always going to be resistance is equal to voltage divided by the beg your pardon, let me just pause a minute. So now I'm working on the right thing. So the current is the voltage divided by resistance. So I've got 5 volts as we just worked out, and a 3 ohm resistor. So therefore then that just gives us a nice little current. So there we have it, 1.67 amps. So we've got 1.67 amps flowing through that resistor there. Okay, so we'll move on to another example then. Okay, so in this question here, we've got the primary voltage 3 volts, secondary voltage 21 volts. So we've got an increase in voltage there, so it's a step up transformer. So it's always the voltage that talks about that when we're talking about either step up or step down. And in this case, we don't know what the primary windings are. So I'm going to start off by writing out the equation. Just so that we've got that, and then we can insert all the rest of the values. Okay, so there we go. We know that's everything that we know. So then we can then start to look to rearrange. Okay. So just finishing off the last little bit there, so we can then say a number of windings that we've got is 100. Okay, does that work? So we're 100 windings on the primary. Secondary winding is 700. Is there an increase in windings because we've got an increase in voltage from primary to secondary? Yes, it is. So it looks like we are going in the right direction. So you should always have a clue whether you're going in the right direction or not. Okay, one last little bit just to finish us off with this one. Let's talk about some current. And we'll shake this up a little bit more. Okay, so same as we did before, let's work out what the current is in the secondary. So we'll call that I2. So I2 is going to be equal to voltage divided by resistance. So we've already said that we had 21 volts there in the secondary, divided by, 10 ohms. So what's that equal to? So 2.1 amps. Okay, right. So what I want to do now is look at, on the extreme chance of a question, that we want to know what the current is in the primary. Now we have to turn our formula upside down for this. So let me just scroll down a touch, and then we can do that. Okay, so looking at our formula, I could have done this with voltage, all the windings. So number of windings primary to winding secondary is equal to the current in the secondary divided by the current on the primary. So opposite way around. The idea being you can't get something for nothing. So we see that certainly with a step up transformer. So if you've got an increase in voltage, just something's got to give. So it's what it is giving is the current. Okay, so let's pop this into our formula so we can then work out what the current is in our primary. So I'm sure there's probably more elegant ways that I could have expressed that, but I'm just keeping it all the same. So 1/7, I'm just bringing down here, so actually it works out to be 2.1 times by 7 gives us our 14.7 amps, but I say I'll just keep my manipulation exactly the same as I've done previously. Okay, so we can see that. So we've got a step up in voltage, but what's happening to the current from primary to secondary, that it's going down. Okay, but it's less likely that you're going to get calculating the current from primary to secondary. But there you have it anyway.